Welcome to this video all about the Webb Space Telescope and infrared light. I'm Dave Eagle. I run the Stargazing Mobile Planetarium. This video was funded by Universal Space. When white light passes through a prism, it produces a spectrum of visible light, and we see that in the colours of the rainbow: red, orange, yellow, green, blue, indigo and violet. There is much more to light than we can see. Visible light is only part of the electromagnetic spectrum. Light is in the form of waves. There are shorter wavelengths of light beyond violet light that we cannot see. This is ultraviolet light. Then there are the X-rays. Then there's the gamma rays, the shortest ones of all. At the other end, beyond red light, are the longer wavelengths. There's the infrared, the microwaves, and the longest of all, radio waves. If we observe the universe in those different wavelengths, we get a different picture with different information. This allows us to observe different types of objects. Here is what the sky looks like in visible light. And now using X-rays. Here's our view observing using microwaves. And now here's the view looking at gamma rays. The Webb Space Telescope will be looking in the infrared, so this is the view Webb will see. This is why Webb has special instruments that need to be kept cold. Once Webb arrives in its final orbit, it moves itself so that the sun shield shades the mirror and instruments from the heat of the sun and the Earth. This makes sure that they stay extremely cold at minus 220 degrees centigrade. On the side facing the sun, it warms to a very hot 109 degrees centigrade, which is far too hot for the instruments to work. This is why the sun shield is so important. Here are Webb's four main instruments: MIRI, FGS NIRIS, NIRCam and NIRSpec. Webb's instruments lie on the other side of the sun shield, behind the main mirror. This means they keep very cold to make sure that they work properly and can detect infrared light. Let's have a look at MIRI, the mid-infrared instrument. MIRI needs to be even colder than a minus 220 degrees centigrade on the cold side of Webb. So it has a built-in freezer to cool it to minus 266 degrees centigrade, making it the coolest instrument on Webb. When the Webb Space Telescope is in position and has cooled down properly, it will start collecting data. That data will be sent back to Earth for astronomers and scientists who will use that data to learn a lot more about our amazing universe. The Webb Space Telescope will be able to see deeper into the universe than Hubble. So we will be able to view the first stars and galaxies that were formed in the universe. This will give us clues on how the universe, our Milky Way and solar system were born, as well as many other new surprises. I hope you enjoyed this video all about the Webb Space Telescope and infrared light. I'm Dave Eagle. I run the Stargazing Mobile Planetarium. This video was funded by Universal Space.